Good morning, everyone. Primary 3 Math second term 2021. We will have in chapter 3, lesson 88. Okay. Our objectives of this lesson, we will remember how to arrange large numbers ascendingly and descendingly. And we will add two fractions of equal denominators using models and your own way. And we will solve various problems on it. Our keywords here will be large numbers in order, proper fractions, representing proper fractions using models, and adding fractions. Our tools, we will need booklet, pencil, ruler, and notebook. Our exercises here, remember how to arrange large numbers. Okay, first one here we have, yes, 1032, 5805, 222, 5120 in ascending order from the smallest to the greatest. The smallest number here has the smallest number of digits. It will be, yes, 222. Okay, let's go to another one. It will be, yes, look at the thousands place. It will be 1032. And go to the thousand place, we have here 5 and 5. Then go back to hundreds place. Here we have 8 and here we have 1. Who is the smallest one? Yes, 5120. And the last one will be 5805. Good job. Let's go to the next one. Here we have 2012, 6419. 3744, 1987 in descending order. Descending means, yes, from the greatest to the smallest. Now let's look at the thousands place. Yes, 2, 6, 3, and 1. Which is the largest one here? Yes, it will be 6419. And next one, yes, 3744. And yes, 2012, and the last one will be 1987. Good job. Let's go to another one. Number C, 12,558, 3,890, 11,543, 77,830 in ascending order. Ascending means, yes, from the smallest to the greatest. The smallest number here has the smallest number of digits. Here we have, yes, 3890 has 4 digits only. The rest of these numbers has 5 digits. Look at the thousands place. Here we have 1, here we have 1, here we have 7. Then look at this one number and this number. Here we have 12, here we have 11 in thousands place. Then we will take, yes, 11,543 first, then take 12,558. And the last one will be, yes, 77,830. Good job. Let's go to the next one. I want, yes, ascending order from the smallest to the greatest. Here we have numbers 21,433, 5,203, 69,211, 11,890, 71,014. Look at the number of digits. Here we have 5, 4, 5, 5, 5. The smallest number has the smallest number of digits. Here we have 5,203. Then look at, yes, the thousands place. Here we have 21, 69, 11, 71. Then it will be 11,890. And yes, it will be 21,433. And next one will be 69,211. And the last one will be 71,014. Look here, we need, yes, descending order. Yes, let's go for 45,221, 8,200, 84,431, 32,091. Here we have 28,001. First of all, descending means from the greatest to the smallest. It's search about the number of digits. Here we have 5, 4, 5, 5, 5. Then look at the thousands place. Here we have 45, 8, 84, 32, 28. The greatest number here, it will be 84,431 and 45,221 and yes, 32,091 and 28,001, and the last one, which is the last number, the smallest number will be yes, 8,200. Good job. More exercises of ordering numbers. Here we have which of the following are arranged in ascending order. Here we have some choices and we have choice ascending order. Ascending order from the smallest to the greatest. Read one by one. Here we have 5 digits, 5, 5, 5. Here we have 76 in thousands place, 76, 76, 76. And go to hundreds, 5, 4, 3, 4. It's not an order. Let's go to another one. Here we have 5 digits, 5, 5, 5. And from thousands place, here we have 44, 54, 21, 25. It's not an order. Let's go to the last choice and examine it. It will be 5 digits, 5, 5, 5. And from thousands place, here we have 28, 47, 52, 62. It's an ascending order. Let's go and choose it. Good job. Let's go to the next one, which is yes, descending order. Choose and examine each one. Here we have 5 digits, 5 digits, 5 digits, and 5. Here we have go to thousands place, 28, 97, 52, 62. It's not an order. Let's go to the next one. Here we have 5 digits, 5, 5, 5. Go to thousands place. Here we have 76, 76, 76, 76. It's all equal. Let's go to hundreds place. 5, 4, 3, 2. It's a descending order. Let's go and choose it. Examine the last one to be sure that's not right. Here we have 4 digits, 5 digits, 5 digits, and 5 digits. Let's go to thousands place. Here we have 3, 25, 93, 73. It's not an order. Our choice is number B. Good job. Here we have, if you know how to add two numbers like 2 plus 1 equals 3, then can you add two proper fractions of common denominators? If yes, what is your notice? Okay, how you can add them? Let's go. Watch this video about adding two proper fractions with common denominators and back to work. Here we have an activity. We have here two fraction steps. Each one is divided into 6 equal parts. First one, here we have 6 in denominator and the shaded part is 2. This fraction is called 2 sixths. Second one, we have 6 in denominator and 3 shaded part, which is 3 sixths. Add the two fractions together and shade the sum model. Here we have an empty model and empty spaces. The first space, we will put the first fraction, which is 2 sixths, like this. And the second fraction, which is, yes, 3 sixths in the second part. And put between them plus. Okay, then put equal. First fraction is 2 sixths, then we will color here just 2 squares. And second fraction is 3 sixths, then I will color here 3 parts only out of 6. Then the sum of these two models, it will be 1, 2, 3, 4, 5. 5 colored parts out of 6. It will be like this, 5 sixths. What did you notice here? Yes, the denominator stays the same. Here we have 6, 6, 6. We didn't add the denominators. but we add the numerators only. Here 2 plus 3 equals 5. Good job. Now let's go to notice them. Find the result. The first fraction is 2/4. Second fraction is 4th. If I put this one here in this empty part, it will be like this. This fraction is called what? Good job. It will be 3/4 because we add only the numerator and put the same denominators. It will be 2 plus 1 equals 3 and 4, it will be the same 4. Good job. Here we have 3/8, which is 3 colored parts out of 8. Here we have 4/8, 4 colored parts out of 8. Here we have, yes, both of them here will be 3 parts here and 4 parts here. It will be how many colored parts here in the add model? 1, 2, 3, 4, 5, 6, 7. 7 colored parts out of 8. It will be like this. In our way, it will be the denominators 8, 8, 8. Doesn't it change? Okay, here we have in numerator 3 plus 4 equals, yes, 7. We just add the numerator and keep the denominator as itself. Good job. Now let's go to evaluate this part. Here we have this exercise. Just press pause, then press play to listen to our explanation. In the first one, we have here, yes, 3 parts out of 6. It will be 3 sixths plus 1 part out of 6, which is 6s. Here we have an empty model. Just divide it like this and shade the sum of all parts. First of all, it will be divided into 6 parts, 6 equal parts, and shade, yes, one by one. First one, second one, third one, and fourth one. This fraction is called 4/6. 4 parts out of 6. Here we have, yes, in another way, the denominator is still the same, but just only add the numerator. It will be 3 plus 1 equals 4. Good job. Here we have half plus half. To add these two parts, we will have the same strip of the same side divided into 2 equal parts. We will put the first part and the second part, which is, yes, it's called two halves. Excellent. Which is equal 1 whole or whole 1. In another way, here we have the denominator is still the same. Just add the numerator. 1 plus 1 equals 2. Good job. 2 halves equals 1. You are awesome. Now let's go to our new exercises. Well, this part, adding fractions. Here we have 2/3 plus third. We can represent it on our fraction strip like this, divided into 3 equal parts, as the denominator say. Here we will color 2 parts out of 3 and 1 part out of 3, like this. Then we have, yes, 3/3, okay, which is equal 1. Another way, we can just put the denominator as it is in the denominator place and just add the numerators. 2 plus 1 equals 3. Good job. Next one, we can represent it like this. Divide a fraction strip into 7 equal parts, which is the denominator say. Then represent 3/7 on it and 2/7 on it, like this. Here we have 5/7, 5 parts out of 7. Another way, just to put the denominator and add the numerators, which is equal, yes, 5/7. Here we have fraction strip divided into 5 equal parts. We will shade 2 parts out of 5 and 3 parts out of 5, like this. The resultant, yes, will be 5 fifths, which is equal 1. Another way, just to put the denominator as is it. Yes, then add the numerators. 2 plus 3 equals 5. Good job. Let's go to the next one. Here we have 4 fourths. Yes, yes, like this. Plus 0. 0 means 0 fourths. Then anything plus 0 equals the same thing. It will be 4 fourths, which is equal 1. Now here we have 9 twelfths plus 5 twelfths. Well, yes, just write down the denominator and add the numerators. 9 plus 5 equals, yes, 14. It will be 14 twelfths. Here we have 4 plus 3 fourths. 4 plus 3 fourths. Then put the denominator as it is and add the numerators. 1 plus 3 equals 4. Good job. Equals 4 fourths, which is equal 1. 1 whole. Good job. Now let's go to our evaluation on this board. Just press pause, then press play to listen to our explanation. Here we have in the first one 30 100ths plus 35 100ths. Then we put the denominator as it is like this and add the numerator. 30 plus 45 equal 75. Here we have 7s plus 4 sevenths. Here we have, yes, put the denominator as it is and just add the numerator. 1 plus 4 equals 5. It will be 5 sevenths. Here we have 5 tenths plus 5 tenths. Just put the denominator as it is and add the numerator. 5 plus 5 equals 10. It will be 10 tenths, which is equal 1. 1 whole. Good job. Here we have 2 nines plus 5 nines. Just put the denominator as it is and just add the numerators. 2 plus 5 equals 7. Good job. Deal. Now let's go to summarize our lesson. Here we have adding two proper fractions. Arrange large numbers. Adding two fractions of the same denominators. Representing fractions using any model you can choose. Here we have, you will deduce your own way to add. Our keywords of the next lesson, which is 89, proper fractions representing using models, subtracting fractions, your own way in adding and subtracting fractions. Good job. Thank you.